so many people have signed up for the second day that we're going to have to go at double speed or people are not going to get in, so we're starting now. Colin is going to tell us about snapshotubuntu.com.
All right, I am mic'd. Excellent. So I have 1.5 working days left at Canonical, so I reckon this is a good time to tell you about one of the final projects that I did there while working in Launchpad. That's been my job since 2015. So Launchpad's a development platform for Ubuntu. It fills the sorts of roles that are occupied in Debian by DAC, by the BTS, by UDD, and so on. The Ubuntu archive is set up pretty similarly to the Debian archive in a lot of ways. This is not a coincidence. We put all of the files in a big file system on disk, and then we push them all out as static files using rsync via a mirror network. This should sound familiar. Some of that network is, in our case, operated by Canonical, but most of it's operated by people who have a bunch of disk space and bandwidth to spare and think this is a useful thing to do with it. Either way, clients just end up fetching files over HTTP from whatever mirror they're using. We have a publisher job, rather like DAC, whose job it is to periodically check whether developers have made changes to any suites in the archive and rebuild all the index files for those suites. So those are the packages, sources, release files that apt uses to establish a trust path and figure out what files to download. And in our case, our publisher is implemented as part of Launchpad here. The state of the archive is recorded in our database. Most of the file contents are stored in our file storage service, which we call the librarian. This system has some advantages. It's quite simple. It's very easy to mirror the whole thing using rsync, very simply. And we all more or less understand the operational properties of serving a bunch of static files over HTTP. But it has some disadvantages. If you want to provide different views of the URL structure, or if you want to add anything fancy like snapshots or anything else dynamic, those are quite difficult things to do because you're pretty much stuck with the structure you have on disk, and that's complex and expensive to rearrange. Now, we were aware of snapshot.debian.org. It's a pretty cool and useful service. It does work, however, by importing the archive state into a completely separate system. And if nothing else, that's a pretty big commitment of disk space, tens of terabytes, when in our case we already have nearly all the files right here. So we thought we could avoid that step. One of the things we've been working on for a little while now is a little web service called LP Archive that sits in front of the Launchpad database and librarian, and it dynamically interprets the sorts of URLs that you'd see on a Debian format archive to work out how they should be translated to the appropriate URLs that point to the librarian. We already have to store all the history of every package in Ubuntu. So Launchpad knows when every package was published, when it was removed or superseded. That information is required by the publisher's old workflow, and we're not in the habit of deleting it. This is all stored in the form of history tables in Postgres, so you just get a couple of columns on each row to say when things were added or removed. And with good indexes, that means you can easily query for what packages were published at any given point in time. So all we really had to do was treat metadata files in the same way. So every time we generate a packages or a sources file, we stick that into the database as well, and with all the same timing information. And then we just have to expose an internal API to do the right sort of clever database queries, and everything is fine. The front end itself is less than 300 lines of code. It's very nearly trivial. So the first step was have this service serve just the obvious thing, something very similar to what we have today. But then it was literally just 10 lines of code to add something that gives you an extra optional timestamp segment, and that's on snapshot.ubuntu.com now. We deliberately used a URL format compatible with Debian.org so that the same tools can be made to work with both. With our implementation, you don't have to work out which snapshot is available first. Just pick a time of your choice, as long as it's after about February 2023, which is when we started tracking the extra metadata, then we'll just give you whatever the archive looked like at a given time. We also got Julian from the apt maintenance team to work on some client-side integration. That's in Debian testing. I do not have time to talk about the details of that here, but you can use the --snapshot option to get it to fetch index files for a snapshot and then install from it. And that's pretty useful for arranging for a fleet of machines to all upgrade to exactly the same point in time consistently. That's all I've got.
Thank you, Colin. Next up, Héctor. Okay. And 3, 2, 1, go.
Okay. Hello, everyone. Let me get the slides out there. Just prepared this. Oh.
There was video for a second.
There was no video. Wait. No video? No. It's a shame. Okay, anyway, just talk then. I was going to present about software in the public interest. Okay. Hey. Okay, so there it is. Oh, okay, thank you. Sorry. Okay. So I'm talking about software in the public interest. I don't know if you knew about it. It's a legal entity. So Debian is an SPI project. And SPI is a legal non-profit based in New York, and provides some services to associated projects. And one of the things they do, or we do, accept donations and maintain project funds. We pay for the expenses of all the associated projects. We maintain tangible assets like hardware, maintain and track intangible assets like domains, trademarks, licenses. We sign the contracts. We do accounting, auditing, and provide legal assistance. So recently, we launched with Debian a new reimbursement system, which these guys are the, well, you know them, they're Debian CH, Debian Switzerland, and I wanted to talk about this reimbursement system that Friction has been sponsoring and Stefano has been writing here, and it's been on a beta testing stage. So if you have any expenses for doing your Debian work, anything you think Debian should cover or could help you because you don't have enough resources or whatever, you can make a request here, and then if the DPL thinks this is good enough, then he'll approve it, and then this will be sent to any of the trusted organizations like the Debian Switzerland, SPI, or Debian France, and this will be paid. And so maybe some people you probably already know, but some others may not know this. So you know you have this. Here. So thank all the organizers for the event and all the attendees for coming. So if you have any questions, feel free to ask. If not, then we can move on. Yeah, Ivo? So the URL of the system is reimbursements.debian.net, but we're planning, as we speak, to move it to reimbursementdebian.org. But then it won't be beta anymore. Okay? Well, if not, you can reach me offline.
Next up is Francis. 3, 2, 1.
Hello.
Go.
Hello, everyone. I'm Francis Murtagh. I work with ARM in Ireland. And for a good few years, I've been interested in trying to get TensorFlow packaged, mainly TensorFlow Lite. So it kind of has a long history in Debian, going back to 2018. Mo Zhao done great work and got 1.10 TensorFlow packaged. But it had a lot of issues around Bazel because it's not great for Debian. It downloads a lot of things which doesn't really suit us. But they got it in with Bazel Bootstrap. But yeah, it kind of came out again because it's an awful unstable source, I suppose, and Mo Zhao kind of gave up on it. Then Wookie had another go at it and done a lot of work and patched out a lot of the downloading of dependencies in the TensorFlow source, and he got 2.3.1 into the new queue and into experimental. So I tried to get TF Lite, which is the more edge version of TensorFlow, to work, but it wouldn't work together in the same source to build all together the TensorFlow and TF Lite. But thankfully, TensorFlow added a CMake build option in 2.4, which suits Debian a bit better. But unfortunately, it still downloads dependencies from the internet, which obviously doesn't work. So then Dylan Aisi had another go with TF Lite 2.11 in its own Salsa repo, and he done a lot of work to get it to use system libraries, which suits Debian. But it wasn't fully finished, and he was kind of hoping that it would go into the proper TensorFlow repo in Salsa. So just during the last 2 days, we picked up his work and we patched in some missing dependencies, I think it's FFT2D, actually, that should be, into the source because it isn't packaged yet, but Wookie went ahead and packaged that, and we added a number of other build dependencies. As well as that, we adjusted the source to match this gem low P package, because normally it uses CMake modules to set these include directories, but the CMake module isn't in the package, so I just patched it to make it work for now. Also, unfortunately, flap buffers is not compiled with position-independent code, so I just built it as a static library for now, just to get things working, and push that to Salsa. And yeah, as I said, Wookie packaged the missing dependency. So this would be a potential step to at least get TensorFlow Lite into Debian. It might make things a bit easier as well, because Google kind of breaks a lot of things with every release. So this would at least reduce the number of breaks that would be in each different version. Yeah, so the next steps, tidy up my patches. They're a bit hacky. Upload Wookie's FFT2D package. Get the tflite.so building. Either integrate that into Wookie's packaging and update his packaging, which is version 2.3.1, or else just have it as a separate source package, and then use that to build ARMNN, which is the software that I normally work on, which I spent quite a long time getting that to work, but then Google changed things to require tflite.a, which I need now. So in order to make that work valuable again, kind of need TF Lite. Yeah, so any feedback from the community and from Debian AI, or any downstream people that are interested in TF Lite or TensorFlow, would be valuable. That's it. Thank you very much.
No time for questions, I'm afraid. Moving straight on, Andy Cater. Oh, you're still plugged in. You are.
borrow somebody to
Let me grab the laptop.
plug my laptop in?
That side.
Right.
There you go.
So, 2 slides, essentially. First one says accessibility. Second slide, please. So, my day job, at least in part, is trying to persuade programmers to write good software and make it accessible. And it's a huge subject that is broad and difficult, but we need to do better. So, accessibility is not just fonts and screen magnification for people who are visually impaired. It's not just screen readers or text-to-speech, not just consideration of mouse cursor speed, sticky keys, or keyboard-only navigation. Everybody benefits from good colour contrast and good backgrounds, unless your interface is text-only. We have to worry about subtitles, closed captions, and audio description of presentations like this. It's all of the above. Let's make Debian work for all. We have the URL for the Web Content Accessibility Guidelines version 2.2, which details this in huge detail, along with documentation and test suites. And there is a mailing list at Debian Accessibility at lists.debian.org.
Okay. There we go. Chris, you're up next. Next. There you go. Right. 3, 2, 1, go. Or maybe Kyle's doing the talk, I don't know. Or just use this one, it might be faster.
Okay. So, and now for something slightly different. So, I work for JISC, who's the UK National Research and Education Network, and we're interested in transferring data for long distances. So, this is some work that I've done with some colleagues. When Steve and I were at university many years ago, Ethernet frames were 1,500 bytes. These days, Ethernet frames are 1,500 bytes, typically. My first connection was 10 megabits. Cambridge University's connection, I think, at that time was 10 megabits. They're now up to 100 gigabits. So, you know, it's quite a big difference. So wouldn't bigger packets be nice? Do they make a difference? From the Netherlands to Brazil makes a little bit of a difference. London to USA doubles. Netherlands to London, factor of 4. So it's really interesting, particularly if you're going to ARNet in Australia, where the round-trip time is a quarter of a second. It can make really quite a big difference. However, the thing is, you need to make sure that you don't block ICMP packet too bigs, because otherwise things won't work. And the other interesting thing that we're playing with is the new congestion algorithm BBR3, which potentially make a real difference, particularly on links that seem to be dropping packets. So we try and avoid dropping packets. So anyway, that's it from me. If you want to chat about it, catch me in the coffee break.
Okay. Thank you, Chris. Right. Now, we have a slight change at this point. The next speaker has asked not to be put on video, so for those people on the stream, I'm afraid you're about to lose us. We will be back later.